this case for a categorical variable is a binary predictor variable. And this is an independent variable in a regression model that has two values. And these are usually coded as 0 or 1 to indicate the presence or absence of some situation. So in the property value data that we've been using, we've got real estate transactions from Watauga County, then Burke County, and the binary variable is equal to 1 for Watauga and 0 for Burke. Okay, and these variables are also called dummy variables, dichotomous variables, or indicator variables. Okay, when you include a dummy variable for in a multiple regression model, it shifts the regression line or regression plane up or down depending on the sign of its coefficient. Okay, so let's call these dummy variables D. Okay, this will be a binary predictor which can take on the values of 0 or 1. So here's a simple multiple regression model with a continuous independent variable and then the dummy variable. Okay, so when the dummy variable is equal to 1, you multiply coefficient B2 times 1, and that becomes a single number that can then be added to the constant or the intercept. And when D is equal to 0, the interpretation of the model collapses down to a simple regression model. In this model, the slope does not change, and it's only the intercept that changes depending on the condition or if D is equal to 0 or 1. So here's an illustration of how that works. Here's we estimate a multiple regression model. Y equals B0 plus B1x1 plus B2 times D. And when D equals 1, we've got this blue line. And in this model, B0 plus B2 is the vertical intercept. And then the slope is positive because the line is upward sloping. When D is set equal to 0, the vertical intercept becomes B0. And in this model, the slope of the two variables, or the two lines, are the same. Okay, and with these dummy variables, you can test for interaction effects between two predictors. And what you do, and you can do this with two continuous variables as well, but the interpretation of those are more complicated. So we'll leave that situation for your next statistics class. So, but with a dummy variable, you can take the dummy variable and multiply it by the continuous variable to construct a third independent variable to include in this regression model. And the effect of it, the interaction variable on sales price, or Y, is B3. So then if B3 is statistically different from 0, then that means that the slope of the equation differs when D is equal to 1. If B3 is not statistically different from 0, then the interaction term has no effect, and the recommendation would be to drop that variable from the model. And so this is what the model would look like in three situations if all three coefficients were statistically different from 0. So the red line would be the model when D is equal to 0. When D is equal to 1, and we set the interaction equal to 0, we get the blue line with a positive coefficient on B2, so we get the shift effect, but a constant slope. Okay, and then this third line, this includes, and that should be B3 for the interaction effect. and d times x. Okay, so b2 in this situation, b3 in this situation is positive, so we would add b3 to b1 to calculate the slope when d is equal to 1. And so we get a steeper slope. And so the two situations, blue is really not a situation, it's the intermediate situation, just to illustrate just that intermediate step. And the red line would be when d is equal to 0, and the green line. So the case of a binary predictor is the simplest case. There's other examples of categorical variables that could be included, and this is when you have a variable that takes on more than two levels. Okay, so for example, you might have regional dummy variables. You might have a big corporation that has a lot of retail outlets, and you lump them into different regions for analysis purposes. You might have a four-level categorical variable for the Midwest, the Northeast, the Southeast, and the West. And so then you would, to estimate this, to analyze these in a regression model, you would create regional dummy variables equal to 1 if the state is in the region, if the state of sales is in the region, in this case the Midwest, and 0 otherwise. Okay, and then when you estimate the regression model, you need to drop one of those categorical variables. So in this illustration, I've dropped the West. Okay, so we include, so here is sales. X would be a continuous variable, and then we have dummies that test for differences in the Midwest, the Northeast, and the Southeast. Okay, so the way this is interpreted, if we are trying to predict sales in the Midwest, you would set the Northeast and the Southeast equal to 0, and then if B2 is statistically significant, you would add that to B0. And then there's similar logic for the Northeast and the Southeast. Set the other two dummy variables equal to 0, and then if the coefficient on the Northeast dummy is statistically significant, that would be added in as a constant to the intercept term. And when you have a multi-level categorical variable that you turn into dummies, one has to be the base case. In this example, it's the West, and to make predictions for the West, you would set Midwest, Northeast, and Southeast equal to 0, and predictions for the Western region would be just based on B0. Okay, in terms of hypothesis testing, B2 tests for whether the Midwest is different from the West. B3 tests if the Northeast is different from the West. B4 tests whether the Southeast is different from the West. So your base case should be chosen with some care. Okay, if you think you have, in this example, a large region or the first region or some other reason to choose one of these as the base case, then that would be the dummy variable that you leave out. Now let's say you want to test whether the Midwest is different from the Northeast. And that can be done. One simple way is to change up the base case. So in that situation, you might drop the Midwest variable from the model and include the West variable, and then the coefficient on the Northeast, B3, would be a statistical test for whether the Northeast is different from the Midwest. And that's a kind of a clunky way to do it, but that's as far as we can get in Stats 2 and in more advanced statistical courses, say econometrics in the economics department, applied econometrics, which is being offered in the fall. You can do, in this model, conduct statistical tests for whether B2 is equal to B3. Okay, and then another topic in section 13, this is in section 13.6, is nonlinearity. We've talked about in chapter 12 how to estimate a nonlinear model with natural logs. And we also introduced quickly introduced the quadratic model. In the quadratic model, you can take any continuous variable and add a squared term and estimate a curvilinear relationship. You can also do this with a cubic function. Okay, if you, in addition to the squared term, you can add multiply the x variable by x again and get the cube term.